Okay, Justin Lovell here, talking with Jeff Moss from Moss LED.
Hello again.
Just finishing off some other conversation. We talked a little bit about the DP making a decision on whether to use a daylight LED or a tungsten LED or a bicolor one, or what's becoming more increasingly popular is like RGB based LEDs, and what the differences are on why some are more color accurate than other ones as they kind of come down the line of technology.
Yeah, so I guess it all comes down to what your shooting environment is. So if you're shooting or you're trying to match your LED to other traditional tungsten or halogen sources, then you want to go to a tungsten tuned LED, which is somewhere in the ballpark of 2800 to 3200 Kelvin. And then if you're always trying to match to, say, outdoors or fluorescence or something, then you probably would want to be closer to a daylight LED, 5600 to 6000 Kelvin. And now you have the option, though, a lot of LED manufacturers like ourselves have a bicolor option, which essentially, if you're selling the exact same product, you take half the LEDs that are on that product and replace them with another type of LED. So now for our products, you have a 3000 Kelvin up to a 5600 Kelvin, and then that's tunable and you can go anywhere in between. So typically you can match your daylight sources and your tungsten sources or anything in between.
And there's no way to have a single LED that is daylight and tungsten. You have to have one or the other. You blend them.
That's right. Yeah. Yeah. So there are new LED chips that are coming out that will have a small tungsten and a small daylight in the same chip package. But right now we find that we can get a higher color quality out of having them completely separate.
Okay. And then so there's also, once you go to a fixture that's got daylight and tungsten on it, you lose a bit of the output because you got to put twice as many LEDs on.
Yeah, that's right. Yeah. So once you LEDs are always attached to a circuit board of some sort, and that circuit board can range in very, very small to relatively large. So that square footage, if you want half of it to be tungsten, then you have to remove half of your daylight chips or vice versa. So yeah, you do lose output on your overall light if you're doing bicolor versus just warm light or a cool white.
And then the converse, if you wanted to make it still keep the same intensity that it had as originally all daylight or all tungsten, you have to pack it pretty densely with LEDs. But in turn, you're probably not going to be able to battery power that because the draw is quite high.
Your draw is really crazy, yeah. And the other option too is our LED, most of our products, we derate our LEDs. So say for example, one LED is typically rated at like 60 milliamp draw. We will derate it so that it's drawing maybe only a third of that, and that means that it just lasts longer. And if there's any heat that is coming in contact with the LED, it can handle that additional heat because it's already derated. So one other option that we have on some of our new products is even though we're removing half the LEDs, we're then driving the other ones harder. So there's a trade-off to that, though, that they may not last as long as the traditional when we're derating each LED.
And what's the typical lifespan of an LED normally versus driven harder?
I would say our harder ones, we would, I think that our newer warranty on them is going to be in the 30,000 hour mark, as opposed to the ones that are more traditional and derated, we're in the 50,000 hour mark. Okay. So not quite half, but close to that.
Yeah, you'll probably be replacing the fixture before you have to worry about that anyways.
Probably, yeah.
So then about RGB, because it seems to be the hot new thing everybody wants to have. Before it was like, you gotta have bicolor, everyone's gotta have bicolor. Now you got bicolor, now everybody wants RGB, which I find RGB, it can either be used for effects and painting backgrounds and things like that, or it can be used quite well to match environments. So RGB, as it could just be kind of like something you think you need but you don't need, or it could be something that can actually be quite useful in an environment where you have something that's got a green shift or a magenta shift or something like that.
Yeah.
So maybe you could talk a little bit about what makes the RGBs that you're putting together different maybe from other ones, or why your color accuracy is a bit better. on certain RGB LEDs?
Yeah, sure. So I guess the newer products that we're launching and have launched in the past year have a tungsten chip and a daylight chip and an RGB, and that's specifically so that you can then shift your white point to to be plus magenta or plus green, or add in a little bit more blue and get your overall color temperature even higher. So I think I touched on this a little bit in the last video about the black body curve on the color spectrum. So that black body curve is keeping your white light as white as possible, so you're not getting any kind of magenta green. When you have, I should say, our LEDs are tuned to 3000 and 5600, and in that spectrum there between the two of them, it's almost on the black body curve the whole time. But shifting between color temperatures, you can't achieve that perfect spectrum without adding in a little bit of magenta or taking away a little bit of green. So adding in the RGB chip allows you to do that. And then it allows you to go further too, so even lower CCT or higher CCT, which will help you match either outdoors better, or fluorescence better, or very warm sources like candlelight better as well.
Right, so then you'll hear about different companies doing like an RGB CW, WW, RGBA, RGB, all these different things. Maybe you can explain what each of those might mean and which ones might be more color accurate.
Oh boy, that's a loaded question.
Yeah.
I guess, I can't speak to other manufacturers about what their accuracy is like. We haven't done a lot of testing to any other LED manufacturers. But essentially, the more points of reference that you can throw at that output, the more chance you have to control the overall output of your light. So if you have an RGB and an amber and a warm white and a cool white, then you can shift that color to be anything that you want pretty well. The more sources, the better. There's even new fixtures out that are RGB, amber, and white, and cool white, and UV, which is a new thing, more for special effects, but that's a trend as well.
So what's the difference between then RGB amber and RGB warm white, which would be tungsten, I guess?
Right. So red, green, blue, and amber are all very specific points on the color spectrum, as opposed to a warm white, which should, if it's a good quality LED, cover most of the visible spectrum of light. So that means that there's a bit of red in that warm white, there's a bit of green, there's a bit of blue, and that's what makes the whole output actually look white. Mm-hmm. So amber is a very specific color versus that warm white covers the whole spectrum.
Right, so to get more accuracy, you probably would want to look at something that's got a warm white and an amber, or just the warm white and a cool white, or?
There's a lot of amber in that warm white, so you typically don't need to have that amber chip as well. Right. But it does get you those richer oranges if you want a really specific orange. Going from, I find personally with when you're trying to match colors and whatnot, if you want to match, say, some really obscure gel colors that's in front of a halogen source with an LED, it helps to have as many points as possible. The white light really adds in a nice even curve, so you can get really nice like pastel colors, as well as using the red, green, and blue to kind of mix it to where you need it to be.
Yeah, okay. Great, well, that all makes sense. I guess you've decided to go with something that's the RGB cool white and warm white. You find that color science, based on those, you can get the colors pretty accurate for color rendering?
Yes, yeah, absolutely. So we're working on control systems now that would take you from very, very warm, so like 1500 or 2000 Kelvin, all the way up to 10,000 Kelvin. The way that we'll keep it on that black body curve and keep our CRI and TLCI, everything high, is by adding in a bit of red, green, and blue as you move through that spectrum of white light. And that's really the only way to get like really high CRI, good color quality, from a low CCT up to a high CCT.
Okay, great.
Yeah.
Well, if you guys want to see anything more that what Jeff's doing here at Moss LED, you can probably come by your office.
Yep.
We'll put a link to their website and information on there. And yeah, they're doing all kinds of crazy different setups for these like mats. So you can pretty much do anything you want with them. It's all custom. So check it out if you want. Thanks.
Thanks.